Welcome to AI Peer Review, the show that extracts the most important nuggets of knowledge from the cutting edge of AI research, tailor-made for you. We've all been watching the incredible progress of AI, particularly large language models or LLMs. They've become, well, phenomenal at finding information, whether it's based on simple keywords or even understanding the subtle meaning behind your words. But here's where the challenge really emerges. What happens when your query isn't just about finding information, but about demanding genuine, complex reasoning?
Exactly. Imagine asking an AI to solve a tricky multi-step math problem, right? Or maybe to debug intricate code or synthesize evidence across multiple scientific papers for a really nuanced answer.
Yeah, those aren't simple lookup tasks where you just match a keyword or a phrase.
Not at all. They require a model to, think step by step, to connect disparate pieces of information and logically deduce the most relevant outcome. That's a whole different ballgame for information retrieval. It's moving beyond simple matching to, well, true understanding.
And that's precisely what we're diving into today. We're cracking open an interesting paper titled ReasonRank, Empowering Passage Ranking with Strong Reasoning Ability. Our mission today is to unpack how ReasonRank, this novel re-ranker, pushes the boundaries of passage ranking, how it injects powerful reasoning capabilities directly into LLMs.
We'll explore its ingenious methods for generating that reasoning-intensive training data, its unique two-stage training approach, and then, reveal its surprising performance and efficiency gains.
By the end of this deep dive, you'll have a shortcut to understanding how researchers are bridging that gap, between simple matching and deep, step-by-step reasoning in AI-powered search.
Exactly. This will give you key insights into the future of intelligent information systems, showing how we're moving closer to AI that can truly think about the information it's providing.
Okay, so with that exciting potential established, let's talk about the obstacle ReasonRank aimed to overcome. What was the central challenge these LLM re-rankers faced? We know LLMs have transformed passage ranking.
Oh, definitely.
Yeah.
Traditional search might just give you a giant pile of results based on keywords.
Right.
But an LM-based re-ranker can take those initial results and smartly reorder them, making the most relevant ones float right to the top.
And they're particularly good at this list-wise ranking thing, right?
That's right. The effectiveness of LLMs here, especially with list-wise ranking, has been a game changer. Instead of evaluating one passage at a time or comparing just two side by side,
It looks at the whole list.
Exactly. List-wise ranking evaluates a whole list of passages simultaneously. Think of it like this. Instead of judging each ingredient in a recipe individually, list-wise ranking lets the model see how all the ingredients combine, how they form the complete dish.
Ah, okay. So it gets the bigger picture.
Precisely. It allows the model to understand global relevance patterns across the entire context. It can refine the initial retrieval results far more comprehensively. It's truly shown state-of-the-art performance on many IR benchmarks by considering the relationships between all the potential answers.
And alongside this, we've seen the rise of these large reasoning models, LRMs like DeepSeek R1. These models are impressive because they can perform step-by-step reasoning during test time. They show their work, basically.
Yeah, they lay out their thought process. And that leads to much more accurate answers for complex problems. So the idea is, this explicit reasoning capability is incredibly desirable for complex passage re-ranking.
Makes sense. If a model can walk through the steps to solve a problem, why can't it walk through the steps to find the best information to solve a problem?
Indeed, the motivation is clear. And some recent studies have tried to inject this reasoning ability into passage re-rankers. And they have shown better performance than models that just, output a final ranking without those explicit reasoning steps.
But there's always a but, isn't there?
Well, yes. Despite the power of these LRMs, existing re-rankers still struggle significantly in genuinely complex ranking scenarios.
So why? If the reasoning models exist, why do the re-rankers hit a wall?
This is where the paper highlights a critical issue: the scarcity of reasoning-intensive training data.
Ah, the data gap.
Precisely. Most traditional datasets, like, say, MS Marco, they're built for relatively simple lexical or semantic matching. They're great for queries like, what is the capital of France? Or who invented the light bulb? Where a direct answer or a closely related passage is enough.
They don't require much deep thought.
Right. They don't require the model to logically deduce, synthesize, or apply multi-step reasoning, but contrast that with real-world queries, maybe from platforms like Stack Exchange, which involve complex Q&A for domains like robotics or biology, or debugging intricate code.
Or complex math problems.
Exactly. Math problems that demand deep reasoning, evidence synthesis across multiple statements, or applying methodological logic to find truly relevant passages.
So the models are trained on simple stuff, but then expected to perform complex reasoning in the wild. That's the data gap you mentioned.
That's it. It prevents current re-rankers from generalizing effectively to these more demanding scenarios. It's like training an athlete by only letting them jog on a flat track,
Right.
then expecting them to climb Mount Everest.
And you can't just hire people to make this complex data, right?
Well, you could try, but manually creating high-quality, reasoning-intensive training data for these complex queries, it's astronomically expensive
Yeah.
and just unfeasible at scale. Imagine hiring experts in quantum physics, advanced math, complex coding.
To label thousands and thousands of examples with detailed reasoning steps.
Yeah, it's a massive, pretty much impossible challenge.
Okay, so ReasonRank steps in with an elegant solution, a two-pronged approach. Prong one is this automated data synthesis framework, basically building a reasoning data factory.
That's the crucial innovation, constructing high-quality, reasoning-intensive training data without human involvement in the labeling.
How do they manage that?
They did it by intelligently sourcing training queries and passages from 4 distinct challenging domains, carefully selected to mirror the kind of complex reasoning humans perform.
And these domains sound really diverse. What were they?
Okay, so first, complex question answering. They pulled queries from various Stack Exchange subdomains. Think biology, earth science, economics, robotics, Stack Overflow, sustainability.
Wow, a lot of variety there.
Yeah. And for these, relevant passages provide key concepts, evidence, or solutions that require synthesis. Like a query might ask about long-term effects of microplastics, varying across trophic levels. You need to piece that together.
Not just find one sentence. Okay, what else?
Then, for coding, they use leak code problems. Here, relevant passages aren't just code snippets. They share underlying algorithms, design patterns, similar logical approaches. Think debugging complex recursion. The relevant passage might explain an iterative approach or an edge case.
Got it. Makes sense for coding.
For math, they drew from the math dataset, focused on 2 tasks: finding passages with similar problem-solving logic or passages with the specific theorems needed. So for a calculus problem, passages explaining integration techniques or relevant theorems.
And the fourth.
And finally, to make sure it could still handle everyday searches, they also incorporated web search using the MSM ARCO dataset. This ensures ReasonRank maintains general ranking ability for simpler queries, too.
So a really broad spectrum, covering simple to highly complex.
Exactly. Designed to push the boundaries. Now, the real secret sauce here is how they generated the labels. They leveraged DeepSeek R1, that powerful LRM, as the teacher.
Okay, so the LRM generates the data.
Yes, it automatically mined positive passages, the relevant ones, and crucially, hard negative
Lots
passages.
of hard negatives. So those are the tricky ones, right? Similar topic, but wrong answer.
Exactly. They might share keywords or topics, but are ultimately unhelpful or misleading. Forces the model to learn subtle distinctions.
And you mentioned a key detail that sets their approach apart.
Yes, this is important. During the positive mining phase, DeepSeek R1 was supplied with the gold answer of a query.
Ah, so it wasn't just figuring it out blind, it knew the right answer beforehand.
Correct. This isn't pure teacher distillation. Giving the teacher the answer up front enhances its understanding. It allows it to generate much higher quality labels. These labels include the reasoning chains, that vital think process, the step-by-step logic, and the gold ranking lists, the answer output.
Can you give an example of that think process?
Sure. Imagine a Stack Exchange query like, explain trade-offs between database indexing strategies for high-volume writes. DeepSeek R1, knowing the correct pros and cons, might generate. Think out, okay, user wants indexing for high writes. Need passages on different index types, write performance, trade-offs.
Yeah.
Prioritize B-trees, hash indexes, maybe inverted indexes, focusing on insertions updates. Think.
And then it outputs the ranked list in the answer tag.
Precisely. But they didn't stop there. They added quality control.
How so?
A clever self-consistency data filtering mechanism. It calculates the NDCG at 10 score for the generated gold lists against simpler point-wise labels. Anything below a certain threshold, they used alpha 0.4, gets filtered out.
So only keep the high-quality synthetic data.
Exactly. This resulted in about 13,000 high-quality, diverse training samples, all synthetically generated, ready for stage 2.
Okay, so that's the data factory. Super innovative. But collecting data is only half the battle, right? Prong 2 is the 2-stage post-training approach, taking that data and teaching the model.
Right. Turning that initial understanding into mastery starts with stage 1, cold start supervised fine-tuning, or FFT.
SFT, okay.
Here, a backbone LLM they used Qwen 2.57b Instruct, or the larger 32b version, is fine-tuned directly on that big synthetic dataset. It learns the reasoning pattern, that whole think process, and how to produce the re-ranked list in the answer tag.
So stage 1 is about learning the structure and the format.
Pretty much, laying the groundwork. Then comes the really refined part. Stage 2, reinforcement learning with a unique, multi-view ranking reward.
RL, okay. But why a special reward? Why isn't something standard like an ECG at 10 good enough?
That's an important technical nuance.
Yep.
Standard NDCG at 10 can be suboptimal for this kind of ranking, especially with the sliding window-based list-wise approach.
Sliding window. Remind me how that works.
So the model processes the passage list in chunks, say 10 passages at a time. It ranks that window, then the window slides over to the next 10, maybe overlapping a bit.
Okay, so it's processing the list piece by piece.
Right. And optimizing only for NDCG at 10 within that small window can cause problems.
Like what?
Well, imagine you have a really relevant passage, but to maximize the score in the current window of 10, the model ranks it at position 11.
Okay.
That passage might then fall out of the window. It won't be considered for propagation to the next window. You might lose good results down the line.
Ah, I see. Focusing too much on the immediate window hurts the overall ranking of the full list.
Exactly. A single metric doesn't capture that need to keep good stuff flowing through the windows.
So ReasonRank designed this ROM, the multi-view ranking reward. What's in it?
It's quite sophisticated. It combines several signals. First, standard NDCG at 10 for overall ranking quality. You still need that.
Makes sense. Put the best stuff at the top.
Second, recall at 10. This is vital to make sure relevant passages stay high enough within the top 10 to get propagated to subsequent windows.
So don't lose the good stuff early. Okay. What else?
Third is rank biased overlap, or RBO. This is more nuanced. It measures how closely the model's ranking matches the perfect gold ranking list. But it gives much more weight to agreement at the very top. It's sensitive to getting the most important results right.
Interesting. So multiple ways of looking at ranking quality.
Yeah, and they also included format rewards, just to make sure the output sticks to the think and answer structure. This whole reward system is then optimized using the GRPO algorithm, a solid RL technique.
That sounds like a really thorough way to train the model, capturing local quality and global coherence. So the big question, after all this ingenuity, how did ReasonRank actually perform? Did it pay off?
In short, yes, in a very striking way. ReasonRank achieves state-of-the-art effectiveness. Across reasoning-intensive IR benchmarks like Bright and R2MED, ReasonRank, both the 7B and 32B models, significantly outperformed existing baselines. We're talking rank T5, rank Zephyr, rank 1, rank R1, rank K.
It beat them all.
Significantly. For example, the 32B ReasonRank model beat the previous state-of-the-art, rank K, also 32B, by about 5 points on Bright. That's a big jump. If you look at figure 1 on the left, or tables 1 and 2 in the paper, the dominance is really clear.
And you mentioned something particularly fascinating about the smaller model.
Yes, this is where it gets truly interesting. The 7B version of ReasonRank often outperformed even the 32B scale baselines from competitors.
Wow. A model nearly 5 times smaller beating the bigger ones.
Hands down, in many cases. Think about that. The implications for cost, energy deploying on smaller devices, it's huge. It really challenges that bigger is always better idea for LLMs. It suggests that smart data design and targeted training can be incredibly powerful.
That's a key insight for anyone thinking about practical AI deployment. Did it generalize well, too?
It did. It showed strong generalization on the traditional BAR benchmark. Proves its versatility. The performance gap wasn't as massive there, but that makes sense. BIR queries are simpler, less reasoning-heavy, so the specialized training advantage is less pronounced.
Okay, effectiveness is clear. Now here's something that sounds counterintuitive. You said it's efficient, despite doing all this reasoning.
Surprisingly, yes. The list-wise 7B ReasonRank is actually 2 to 2.7 times faster than a point-wise re-ranker like rank 1 7B.
Faster?
Yeah.
How? Reasoning seems like it should take more time.
It's a fantastic finding. It comes down to the list-wise approach again. Remember how point-wise rank 1 generates a reasoning chain for every single passage?
Right, lots of computation, lots of output tokens.
Exactly. ReasonRank, being list-wise, generates only one reasoning chain that the whole batch of passages is looking at in a window.
Ah, so the reasoning overhead is amortized, spread across multiple passages.
Precisely. It significantly decreases the total number of output tokens. Much lower latency. You can see the speed advantage visually in figure 1, right? In figure 4 in the paper.
Very clever, spreading the cost of thinking. And they did ablation studies to confirm all these parts were necessary.
They did, comprehensive ones. And the proof is clear. Every component contributes significantly. Removing the diverse reasoning data, performance drops. Taking out the SFT stage, drop. Disabling RL, drop. Removing the multi-view reward, big drop.
So everything matters. What about the reasoning part itself?
Crucial. They tested a non-reasoning SFT re-ranker, trained without the think chains. It had a substantial 2.78-point performance gap compared to the full ReasonRank. Unequivocally shows that explicit reasoning significantly enhances effectiveness. It's not just fancy decoration.
Wow. And there was one more really remarkable finding, wasn't there, about outperforming the teacher?
Yes, perhaps the cherry on top. The 32B ReasonRank achieved comparable or even superior performance to its much, much larger teacher model, DeepSeek R1.
The 671 billion parameter teacher.
That's the one. On the bright top 20 re-ranking task, a 32B model matching or beating a 671B model.
That's incredible. How is that possible?
It speaks volumes about the power of that automated data synthesis framework. By giving DeepSeek R1 the gold answer during label generation, basically, giving it the perfect blueprint, ReasonRank could effectively distill that knowledge, and maybe even surpass the teacher's performance on these specific reasoning tasks, even with a vastly smaller model. It's a testament to high-quality, task-specific data.
And they even found ways to potentially boost performance further.
Yeah, small things like using better initial retrievers to feed passages into ReasonRank, or just optimizing sliding window parameters like window size and stride. Smaller windows that seem to help, likely making the ranking task within each window a bit easier. So room to squeeze out even more performance.
Okay, let's recap this deep dive then. We've unpacked ReasonRank, a really groundbreaking approach. It tackles that critical challenge of reasoning-intensive information retrieval head-on.
Its core innovation is that automated data synthesis framework, creating high-quality, diverse reasoning data without needing human annotators, solving a huge bottleneck.
And then there's the sophisticated two-stage training. SFT followed by RL, using that novel multi-view ranking reward to really hone its reasoning and ranking ability.
Yeah, ReasonRank isn't just about getting slightly better search results. It's about pushing AI models to genuinely understand and reason through complex queries, not just match keywords.
And it highlights something important. Carefully curated synthetic reasoning data can empower even smaller LLMs.
Absolutely. Empower them to achieve state-of-the-art results with surprising efficiency. This really changes the cost-benefit analysis for deploying powerful reasoning AI.
So what does this all mean for the future? What's the final thought for our listeners?
Well, consider this. An approach where smaller models can learn to outperform their massive teachers by training on a highly specialized, reasoning-intensive data. Could that fundamentally change how we train and deploy AI for all sorts of complex tasks, way beyond just search?
Could this be a blueprint, maybe, for making AI not just knowledgeable, but truly insightful and efficient across many different fields?
It certainly gives you something profound to think about. How targeted data and smart training might unlock capabilities we didn't think were possible, at least practical, until now.